Hello, welcome to Math. Prove that integral x squared dx equal to 1 over 3x cubed plus c. Let's write our solution. Let's repeat this one. Integral x squared dx. Here, we are going to rewrite x squared using natural log. Okay, so let's write. Now, when we write x squared using natural log, we are going to get e to the power ln x squared. Okay, so let's write. Integral e to the power ln x squared dx. Now here we are going to do substitution. So substitution. We will let u equal to ln x squared. Okay, so let's write. U is equal to ln x squared. Now here, from the laws of logarithm, these two here can be written here. Okay, we will just write these two here. Okay, so let's write. Here we are going to divide both sides by 2. We divide this one by 2, divide this one by 2. Okay, all because we want to get x before we differentiate. Okay, so let's write. Now when you differentiate 2 ln x by 2, you are going to get ln x. When you divide 2 ln x by 2, we are going to get ln x. And when you divide u by 2, we are going to get u over 2. Okay, so let's write. Here, to get x, we apply the definition of logarithm. So from the definition of logarithm, x is equal to e to the power u over 2. Okay, why? Because the definition states that log of a number, say a or e, is the index to which the base must be raised to give the number. So if we want to get the number, which is the x here, we have to raise the base, which is e, of this natural log by powering it with u over 2. Okay, so x is equal to e to the power u over 2. Okay, so let's write. X is equal to e to the power half u. So here we are going to differentiate. So differentiate. Now when you differentiate this, you are going to get dx is equal to half times e to the power half u du. Okay, so let's write. Now let's put this one into the integral and proceed from there. So let's write. Here we are going to write this half here outside here. We will just bring this half here outside here. Okay, so let's write. Now here, half integral e to the power u times e to the power half u du. Now here we are going to apply indices here. That is, when the base are the same and is multiplying, we just add the exponent. Okay, that is the base of e. The base of this u is what? E. And the base of this half u is also e, meaning they are multiplying. And from the laws, when the base are the same and they are multiplying, we add what? The exponent. Okay, so we're just going to add this u to this half u here. Okay, so let's write. Now u plus u over 2. Now when you add this, you are going to get this one. So 2 times u give us 2u plus this one give us 3u. So when we add this, we are going to get 3u over 2, 3u over 2. Okay, so let's write. Half integral e to the power 3u over 2 du. Here we are going to do substitution just to make the work easier for us, just to make the integration what easier. Okay, so let's do another substitution so that integrating will be what easier. So substitution, we will let m equal to 3 over 2u. Okay, so let's write. Now here we are going to differentiate. So differentiate. Now when you differentiate this one, you're going to get dm is equal to 3 over 2 du. Okay, so let's write. Now here, to get du, we are going to multiply through by 2 over 3. 2 over 3. So we multiply this one by 2 over 3, and then we multiply also this one by 2 over 3. Okay, so let's write. Now when you multiply this one by 2 over 3, then you multiply through by 2 over 3, sorry. This will cancel this, and then this will also cancel this, and to be left with what? Du. Okay, so 2 over 3 dm will be equal to du. Okay, so let's write. Du will be equal to 2 over 3 dm. Now let's put this one back into the integrals, and then let's proceed from there. Okay, so half integral e to the power m times 2 over 3 dm. Now here we are just going to bring this 2 over 3 here outside here to multiply this one. Okay, so let's write. Now when you multiply this one by this, these two and these two will cancel out, and we are going to get 1 out of 3. Okay, so we are going to get 1 over 3 integral e to the power m dm. Okay, so let's write. One over 3 integral e to the power m dm. Here, to integrate this one, you see this one is much easier than the first one. Okay, so when we integrate, we are just going to get 1 over 3 e to the power m. Okay, if we integrate e to the power m, we are going to get e to the power m, and then we multiply it with this 1 over 3 here. Okay, so we are going to get 1 over 3 e to the power m. Okay, so let's write. Now 1 over 3 e to the power m. Now we need to go back. We are done with the integration, but we have to go back to the x world. Okay, so here we are just going to put m is equal to 3. So here I'm just going to put m is equal to 3 over 2u. 3 over 2u, because we substitute this one during the workings. Okay, so let's replace this m with this 3 over 2u. Okay, so let's write. One over 3 e to the power 3 over 2u. Now, like I said, we are going back to the x world. Okay, so still we haven't reached the s world yet. There is u here, but we know that u is equal to ln x squared. We know that u is equal to ln x squared. So we just replace it with this u. Okay, so but u is equal to ln x squared. So wherever we see this u, we will just put this one there. Okay, so let's put this one here. Okay, so let's write. Now here, this 3 over 2 here is going to multiply this power 2 here because of the laws of what? Indices. Okay, so let's write. Now when we multiply this power 2 with this one, these two will cancel out with these two and it will be left with what? 3. Okay, and that is going to give us 1 over 3 e to the power ln s cube. Okay, so let's write. Here, the base of ln n and this e will cancel out. The base of this natural log is e, and we are having another e here, so they are just going to cancel out and to be left with what? S cube, and then we multiply it with this 1 over 3. Okay, so let's write. So therefore, integral s squared dx is equal to 1 over 3s cubed plus c. Okay, now we are almost done with everything. Now you can see that the workings from above tell us why that when you integrate x squared dx you get 1 over 3s cubed plus c. Okay, so now let's look at the differentiation aspect of this question. Proof of differentiation. So let's write our question. X equal to e to the power half u. Here we do another substitution. We here just going to do substitution. We will let p equal to this half u here. Okay, so let's write. Here we differentiate. So when you differentiate this one, you're going to get dp is equal to half du. Okay, dp is equal to half du. Now we are just going to put p back here. We're just going to put p here and then we differentiate this one. So when you put p here, it's just going to give us x equal to e to the power p and then we differentiate. Okay, but let's leave this one for now because we will do substitution. Okay, so let's proceed. X equal to e to the power p. Now let's differentiate this one. When you differentiate, you are going to get dx equal to e to the power p dp. Okay, but we know that dp is equal to but we know that dp is equal to 1 over 2 du. We know that dp is equal to 1 over 2 du. So wherever you see dp, you're just going to write this one there. Okay, so let's continue. Dx equal to e to the power half u multiplied by 1 over 2 du. Okay, now let's open the bracket by multiplying this one with this one. Okay, and when we do that, you are going to get dx equal to half e to the power u du. Okay, so let's write. Dx is equal to 1 over 2 e to the power half u. So this is the reason why the differentiation aspect I had this one. Okay, all right, that's it. Please, if you like this video, kindly give it a thumbs up, subscribe and comment. Thanks for watching.